Hi students, today we are looking at solving problems with expressions, equations, and inequalities. And your learning target is I can solve problems by using expressions, equations, and inequalities. Please write that in your planner for today. And then for this lesson, you don't have to have a highlighter, but it is helpful for the first example. And then you'll need your pencil and your math book to follow along. Just a reminder, you cannot write in your math book unless you have purchased your math book. All right, so let's go ahead and get into this first example. And our first example says, at the beginning of the year, a stock was worth $41, and by the end of the year, its value had increased 18.9%. And so the question wants to know what is, let me find it. This is example 1 on page 77, and it wants to know the stock's final value. So go ahead and either follow along in your book or on these notes with me. So first it's asking us to estimate. And to estimate, we need to round 41 to the nearest 10. And so that would make 41 goes to 40. And 18.9 to the nearest 10 is going to go to 20. And this is 18.9%, so this is also 20%. And then when we're working with expressions, we don't like to have percentages in expressions. So we want to change percent to something we can work with. And you have the choice of either a fraction or a decimal. And I always prefer decimals when I'm doing these problems. So 0.20 is how you write 20% as a fraction. Then it gave us a bar diagram on page 77 to look at. So from here to here represents 40. This represents 40. The whole bar represents 40, or it equals 100%. And we need to break it into pieces of 20%. So you do 100 divided by 20 is 5, so we know we need 5 boxes. 1, 2, 3, 4, 5 boxes. And the whole thing again is worth 40. So the first thing we need to do is find out how much one section represents. So if the whole bar is 40, how much does one of these pieces of 5 represent? Well, I'm just going to do 40 divided by 8. If you know that off the top of your head, it is 5. So this one bar represents 5. This bar is 5, this bar is 5, this bar is 5, and this bar is 5. And they all add up. Oh, I'm so sorry. I did that backwards. I wrote the answer over here. You're supposed to divide by 5. Let me rewrite that. Divide by 5. And I'm so sorry. This is an 8. If you caught me and made a caught my mistake, good job. Okay, so this bar, let me actually erase that so it's super perfect clear for you. This bar represents 8. Sorry. Okay, so 5 pieces, 5 times 8 is 40, or 40 divided by 5 is 8. This one bar also represents 20%, and so 20% is 8. So it's asking us, in the question, it says the value increased by about 20%. So with this bar, we need to add an additional bar onto it because each bar represents 20%, right? So here's another bar that represents the growth, how much it increased by 20%, and we already know that 20% is 8. So it increased by an additional $8. So this bar was about 40, and now we've got another 8 to add on to it. So 40 plus 8 is 48. So this is our approximation. This is a close guess to what the actual value is. But we are able to actually find the actual value, and we're going to do that in section B. So we're not going to be rounding anymore. We're using the original numbers, 41 and 18.9%. And the actual value. So the actual value is the $41. So we know that the $41 was the starting price. And then it increased, which means that we're going to be adding something to that. It increased by 18.9%. But I have a question. 18.9% of what? Of the original value. So of means multiply. There's my multiplication symbol. Of the original value, which was $41. All right, so let's go through and make this a simpler expression because I don't like all these dollar signs and percent signs in my equation. So I'm just going to do 41, that's simple, plus 18.9%. Well, I know I can change this percentage to a decimal by moving the decimal place over 2 times. So now I have 0.189 or 189 thousandths times $41. Oops, and I'm getting rid of my dollar signs right now because I don't want them in my expression. And now I've got some sort of expression that I can work with. So on your calculator, if you have one nearby, go ahead and solve 0.189 times 41 and see what you get. When I did it on my calculator, I got 7.749. So remember when we did the estimation, we estimated and we got 8. Is 7.749 close to 8? It definitely is. So we're on the right track. That's why it's good to estimate first to know if you're on the right track. So 7.749, is that my final answer? No, don't get tricked. A lot of you will accidentally think, oh, I just solved the problem and give me that answer. That is not the final answer because this is how much it increased, but we need to know the final value. So we need to add this to 41. So if you have your calculator still, you can add 41 to 7.749 and you will get 48.749. And instead of 749, we're going to round that to the hundredths place. The 9 makes the 4 turn into a 5, so it'll be 48.75. Is this my final answer? 48.75. $48.75. Yes, that is how much the value went up. It's how much it increased. And please take a moment and compare this answer with our estimation. We got $48.75 as the actual value. Well, look, we got $48 as the approximate value as well. So those are very close, which means we probably got the correct answer. And then in this video, let me also go over what we're going to be doing for in-class homework the next time I see you. It will be on page 80. And we'll be working through these problems as a class, but I want to show you one of them now so you can kind of get your mindset going on how these problems work. So go ahead and read number 1. Read it along with me. Turn to page 80. It says Mary got 8 out of 10 questions right on her test. With what percentage increase could her test have been at least a 90? So she got 8 out of 10 and she wanted a 90. Now there's some key words in there. And one of them is this word right here, at least. And this is, I mentioned briefly to you the other day that at least and a few other key terms signify that we're going to be using an inequality. And I'm just going to abbreviate that. It's going to mean that we're using an inequality. Let's look at the words at least, because you will see these in word problems that have to deal with inequalities. So the word at least, well, let's think about it. I'm going to use the example of people sitting at a table. So let's say that I need at least 3 people at a table. So it's going to be some number with 3. And I need at least 3. So am I allowed to have more than 3? Yes, I am. So I'm allowed to have more than 3. Am I allowed to have less than 3? No, because I need at least 3. And am I allowed to have 3 at that table? Yes, I am. So I can have an equal to 3 because 3 is equal to 3. So I'll be allowed to have an equal to. And I also know that whatever number I have either has to be 3 or bigger. So it needs to be at least 3. So whatever number of people are at the table, we don't know. But I'm allowed to have that number bigger than 3 or 3. So I'm allowed to have, if it's going to be at least, it's going to be this kind of a symbol. It's not always going to be a 3, but it's going to be this symbol. It's going to be a greater than or equal to symbol. Okay, then what about no more than? So if I have no more than, let's do the table example again. This time I'm going to say no more than 4 people at a table. So 4 is my number. No more than 4 at a table. So I cannot have more than 4 at a table. So would it be x is greater or is less than 4? Because I can't have more than 4? Yes, because any number that's smaller than 4 is allowed to sit at that table. So am I also allowed to have 4 people at that table? No more than 4? Yes, I'm allowed to have 4. So this symbol is also going to be equal to. So it's less than or equal to right here. Again, it's not always going to be a 4, but it's going to be the less than or equal to. And then these ones are a little simpler, less than. So I need less than 3 people at a table. Less than 3 people at a table. Well, here's my number. Can I have 3 people at the table? No, because I need less than 3 people at the table. So it's just going to be a less than sign. It's not going to be less than or equal to. And then greater than or more than a certain number. So let's use the table again. Let's say I need more than 4 people at a table. I need more than 4 people. So here's my 4. Here's the number of people I don't know. I need more than 4 people. So I need one of these, a greater than symbol. Am I allowed to have 4 at that table? No, because I need more than 4 at that table. So it's just going to be a greater than symbol. And that's it. So it might be very helpful for you to refer to these notes as you do your homework on page 80 in class tomorrow. But it is up to you. And then we are going to do practice page 80, number 1 right now, just as an example for what you should expect in class for tomorrow. So page 80, question number 1, you can do this on a blank piece of paper if you'd like to continue your homework on this for tomorrow. So Mary got 8 out of 10 questions correct on her test. 10. And then with what percentage, so there's a number we don't know, with what percentage could her test have been at least a 90%? And they should have written a percent right there. So with what percentage could it be at least a 90%? So percent, again, means a number over 100, correct? So some number over 100. With what percent could her score been at least a 90? So we've got 8 over 10, and we want to find how much we could have added to her score to have gotten her a 90. All right, and you may need to continue this work on the back of your page. I'm actually going to erase this because I'm running out of room. Okay, so ultimately, this is the equation that you are going to generate because she got 8 out of 10 questions correct, and we want to know how much it's going to take her to get to a 90. And we know that there were 10 questions on the test because it says 8 out of 10 questions correct in the word problem. So we've got 8 out of 10 questions correct on the test, and we're going to be adding something because it's a percent increase, a percentage of 10. So we need to know what percent of 10 did she need to get correct to get at least a 90? And I also just realized I wrote the wrong symbol right here because it says at least. It's not going to be an equal sign. Which one is it going to be for at least? Well, it's going to be this greater than or equal to. So I changed that right here, greater than or equal to. All right, so we know that percentage is some number over 100. Some number over 100. And that's not showing up. Hold on. All right, so x over 100 times 10 is because this percent means per 100 or some number over 100. And we know that 8 goes into 10, and that's going to give her an 80, or 8 over 10 is an 80%. So 80 plus x over 100 times 10 is going to be greater than 90. And then it's your turn to try to solve this one. See if you can figure out what it's going to be. We will go over this again in class tomorrow. And then your last thing is to read this attempt right here that you should try to do in class. But if you don't understand it, we'll go over it again tomorrow.